So the second video that I'm showing you here on quadratics is finding the vertex and finding the line of symmetry. Now, as we said before, if you just have y equals ax squared, I know the vertex will always be 0, 0, and the line of symmetry will always be the y-axis, which is the equation x equals 0. That's always going to be. I don't have to do any math, I just have to know that. When you have to start doing some math is when it's of the form y equals ax squared plus bx plus c. So now we're adding things, which means that's going to move my parabola to anywhere on the graph and is going to move it away from that 0, 0. Now, comparing this to here, we still know that our graph is going to be a parabola. That I still know. Now, and I will also know, is my parabola going to open up or down? So even though there's a bx and a c, I'm still just going to look at a. If a is positive, that means my parabola is still going to open up. And if a is negative, that still means my graph is going to open down. B and C have absolutely nothing to do with whether your graph opens up or down. That still is contingent on what a is, okay? And then, of course, if it opens up, your vertex will be a minimum. And if you open down, your vertex is a maximum. I mean, you can just look at a graph and say, yep, it's the very bottom, or nope, it's the very top, which is basically all we're doing. The difference is over here, again, I knew my vertex was 0, 0 and what my line of symmetry was. Here, I don't know that just looking at this equation. Now, if I could graph the equation on Desmos, so if I had a number, which we're going to do here, I'm going to give you an actual example with numbers. I could plug that into Desmos and I could graph it, or I could graph it by hand and I could say, okay, here's the vertex. And here's the line of symmetry. I can see that on the graph. We can also do that algebraically, okay, so by doing the math, which I think is actually a little simpler. So how do you find the vertex if I can't graph it? Well, you're going to use these numbers up here. We're going to be using whatever number is in the A spot and whatever number is in the B spot, okay? And here's what you're going to do. To find the vertex, okay, to find the x value. So remember, every vertex is a coordinate point, an x value, and a y value. So to find the x value, I'm going to plug whatever b is. Remember, a, b, and c. Those are my numbers for a, b, and c. And you don't really need c, we just need a and b. I'm going to take the opposite of b and divide it by 2 times a. Pretty simple. So if you look at this, if you need to, you can add a line. But my b value is negative 12. So I want to do the opposite of b. The opposite of negative 12 is positive 12. So that's the number that's going to go on top. Okay, over 2 times, and that 2 is just part of the formula, my a value. If you look, 3 is my a value. So 2 times 3. So I'm going to take 12 divided by 2 times 3. We can do that. 2 times 3 is 6. 12 divided by 6 is 2. So the x value of my vertex is the number 2. That's it. Okay? Now, to find the y value. Some of you may think, well, that looks really, really confusing. It's f of the opposite of b over 2a. But we already found that the opposite of b over 2a is 2. So what this means is I'm going to take this x value that I found and I'm going to plug it in for x and find y. So now that I know x is 2, it's kind of like an xy chart. If I know x is 2, I have to plug 2 in for every x value that I see, do the math, and I'm going to get y. So in this case, I'm going to plug 3 times, instead of x squared, it's going to be 2 squared, minus 12 times 2 plus 15. So I just plugged 2 in, and now it's just an order of operations and doing the math. 2 squared is 4. 4 times 3 is 12. 12 times 2 is 24, plus 15. Okay, left to right. 12 minus 24 is negative 12. Negative 12 plus 15 is a positive 3. So my vertex is the coordinate point 2, 3. And you can graph that to double check. You will have a vertex at 2, 3. My a is a positive number, so this graph opens up. Okay, so here's what I know kind of already. I have a vertex at 2, 3. and I know the graph opens up. So it maybe looks something like that. That's just a quick sketch. Now, the line or axis of symmetry. We talked about before how it's always a vertical line, so it's always going to be x equals. X equals opposite of b over 2a. Folks, we already found it. Opposite of b over 2a we already found is 2. So our line of symmetry is x equals 2. Basically, it's the x value of your vertex. The line of symmetry is the x value of your vertex. So if that's 2, that's 2. That was the case over here. The x value of my vertex was 0, so it was x equals 0. Okay, so that is mathematically how you find the vertex and the line of symmetry. It looks intimidating, but really it's just plugging numbers into a formula and doing some pretty basic math. Okay, again, you can always graph it as well. And for what we're doing now, that's okay. You could plug it into Desmos and look and find that vertex. In Algebra 2, you're going to have to be able to do it by hand, so I did want to be able to introduce you to that. Okay, and that is the most basic I can get on quadratics right now. If we were in school, we'd be going much, much further, but that is where we are at.